Hello and welcome to another video. In this video we're going to be working on maximum score words formed by letters. And in this one you're given a list of words, and you're given a list of single letters that you have, and the score of each letter. And you want to return the maximum score of any set of words that you can make using the letters. So basically you have these letters, you can think of it like Scrabble letters, and when you use letters for a word, so let's say you make dog, you'll have to use one D, one O, and one G. And then you can try to make like as many words as you want, and you basically want to maximize the score of your words. So this is literally thinking of it like Scrabble, like I can make all these words, maybe I can't, maybe I don't have enough letters for any of them, but essentially here's all the values for every letter, kind of like Scrabble as well, right? An A is worth this, a B is worth this, a C is worth this, and so on. So that's the score of the letter, so it's 1 through 26, so A, B, C, all the way down to Z. And you want to say like what's the most I can make. So in this first example, we can make dad, which is worth 11 points. We can make good, and that's the best. And then so on and so on and so on for these examples. So it's kind of self-explanatory if you think about it like that, where basically all your letters are worth the same amount. Like every A is worth the same amount, every B is worth the same amount, and so on. And you just pick like which words do I want to make. And if you take a look at the constraints, there's only 14 words, and each word is pretty short, and you have 100 letters. So if you've been following the backtracking stuff that we've been doing for last week, this should be closer to a medium problem, to be honest, and it should be kind of straightforward. The only like even remotely tricky stuff is like how do we do this efficiently. But essentially for every word, we can choose one of two things. We can either make the word or don't make the word. So sounds just like all those subsets problems, right? Like we can either include our word or we don't have to. So the number of combinations of words you can make is 2 to the words, right? Same as all the stuff before. And so now basically it comes down to how do I efficiently figure out like which words to take? Like do I just try every word? You know, what do I do there? So for one thing, some small data stuff. This letter thing is obviously not efficient. Like it's gonna be kind of annoying to just take letters. Like I have an array of letters. I want to take a D. Like what do I do? Like do I make this go away or something? So this is obviously not efficient. So you want to transform your letters into like a dictionary. But I'm gonna say in Java there's something even better you can do. So because you only have 26 letters, I'm gonna say for the letters, instead of making a dictionary, we're just gonna make an array. So we'll just make an array of all the letters and their count. And it's going to be a 26 long array. So 0 to 25. So for example, if 0 has a value of 5, that means the letter 0 has a value of 5, and the letter 0 corresponds with A, this corresponds with B, and so on and so on and so on. So we'll basically just make an array of all the different letters 0 to 25 and how many we have. So that's one thing we can do. In fact, we can even, now that I'm thinking about it, we don't even have to use the letters at all. We can just say, let's just transform every letter into a number. Yeah, I think that might actually be better. So like A will be 0, B will be 1, and so on and so on and so on. So for every letter, we'll transform it into a number, right? So A is 0, B is 1, and so on. So we'll have an array of all our letters. So in this case, let's take a look. So let's see. Let's look at some. Okay. Well, let's say our word is like something that will fit into the first couple. So let's say it's like AA, BB, CC, D or something. So that will basically be, so we'll have 2 A's, 2 B's, 2 C's, 2 D's. This will be our array of a letter count. And now this is more efficient to work with because we know exactly like what letter we need to change and like how much. And we're going to do the same thing with all of these words. So for all of these words, we will transform it into an array of letter counts. Because we're going to need to check a lot, like can we make the word or not? Because in 2 to the n, like there's a lot of combinations where you're checking the same word multiple times. Or you can make like a cached function that does this. Actually, probably you can't because your letter bank is going to change all the time. But then the amount of characters it takes to make the word won't change. So essentially, we're going to transform our letters into an array of 0 to 25 and the counts. And we'll do the same thing for each word. And then to figure out if we can make a word, we're simply going to have an array of our letters. So obviously it's going to be length 26, but let's say we only have 10 characters. So let's say this top one is an array of our letters and this bottom one is an array for a particular word. And like I said, obviously it's going to be 0 to 25, but in this case, we'll just make it smaller. So let's say our letters, all our counts are like this, maybe. Literally like this. And this word takes maybe like 1, 2, 3, 1, 2. Basically, what we're going to do here is, this is our total letter bank, let's call it. And this is our word. Right, so essentially this represents, I have like 3 A's, 3 B's, 3 C's, 3, and so on. And the word takes 1 A, 2 B's, 3 C's, 1 D, and 2 E's. And yeah, for Java, this is going to be a lot more efficient. Using static arrays is going to be a lot more efficient than making like a hash map. In Python, if you're doing some Python, you can make like a counter for all the letters, and you can use that instead. So basically, we're going to check for every character in the word. So we're going to go through all the characters in 0 to 26. And we're going to check, is our count in the letter bank big enough to make the word? And if there's any character that's smaller, then we can't make it. So here, this is fine, this is fine, this is all fine. But let's say maybe this character, like we have 5 of these and we don't have enough here. So we're going to go through this whole thing and we're going to say, oh, we don't have enough here. So we're just going to have like a Boolean value, kind of like we did yesterday, to represent can we make the word or not. And if we can make the word, then what we're going to do is we're going to go through this thing again, and we're just going to subtract all of these counts from our letter bank. So this will go down to 2, this will go down to 1, this will be 0, this will be 2, and this will be 1. And as we do that, we can also increase our score. So when we take a word, we're just going to say, like, what's this letter worth and how many do we have? So let's say these are worth like the same amount as their index. That means we'll add like 0 points here, we'll add 2 points here, we'll add 6 points here, we'll add 3 points and 8 points, right? If assuming like the scores are literally these, obviously they're not going to be. But that's how you would do it. You just figure out like how many of the letter am I adding and what's the score for the letter. Then we just recurse to the next word with our updated letter bank. And for the backtrack part, once we're done trying this word, then we are going to need to update our letter bank again with removing this word. So we will just remove it and reset our count. And also, as we remove these, as we add these characters back in, we're going to decrease the score. And so that's kind of the idea. So for any word, we're just going to check, like, do we have enough characters to make it? If we do, let's update our characters, and let's update our score, and let's recurse to the next word. And then whenever our base case is going to be when we're done trying to make like a subset, like the same as we did before, when we're done with all the words over here, then we're just going to say like, okay, what's our current score? And we'll just keep the maximum score that we made. So that's kind of the idea. So first thing, take this letters, transform it into an array of counts. Second thing, take all of these words, transform them into an array of counts. And third, write the backtracking. And honestly, I think this took me like in Python like 5 minutes to do, so I wouldn't say this is a hard problem as long as you follow the backtracking template, kind of similarly what I did last time. So let's do that. It's going to be a little bit longer in Java, obviously, because we have to make the arrays and stuff. In Python, I just use counters, so it's super fast. Okay, so we're going to have a couple things here, and we'll make some class variables once again so we can access everything. So we'll have a result, just like we did before. We'll have a current, which was like our current score. We're also going to have an array of letter counts. So we'll call this like counts. And we'll have a nested array of word letter counts. So we'll call this like word counts. Okay, so let's initialize everything here. So result equals 0, current equals 0, counts equals new array. And it's going to be, so it's going to be length 26. Because the number of counts we have for every letter is just a new int array. It's going to be, we can only have 26 like different letters, and we'll have a count for all of them. For the words is going to be similar, except it's a nested array. So every word will have 26 different types of letters, and then there are words length words. Okay. So now we're going to go through our letters and transform them into this counts array. So we could say for character C in letters. So like I said, we don't even need to use the characters. We're just going to use integers for everything because that's easier. So we can say counts, and we basically need to transform this character into a letter, and it needs to go 0 to 26. So I talked about this before in Java. In order to do this, basically what you have to do is first you have to cast it to an integer, and then the thing you're casting to an integer is actually the character value minus a. So there's like other ways to do this, but this is one of them. So basically what's going to happen here is the character value minus a will make it like, will make a 0. So if you do a minus a here, that will be 0, b minus a will be 1, c minus a, and so on. If you don't do this minus a, this will get you the ASCII value for the character, which is like 90. And you don't want 90, you want a to be 0, b to be 1, c to be 2, and so on. So that's how you do it. Then we just do a plus plus here. And that should do it, I think. And so then the next thing we need to do is we need to do the same thing for the words. So we can say like for int I equals 0, I is less than a word's length, I plus plus, and this is going to be the same exact idea as this, except we have to do this for every single word. So we can say words I, we'll convert it to character array, which is fine because the words are super small, so it's not costly. So we'll convert it to character array, and same thing. And now instead of this being counts, this is going to be word counts. And so the first index will be the index of the word, which is I, and then the second index will be the letter. So there we go. So now basically we have that. So now essentially we have a nested array where, you know, it'll be an array for every word. It'll be an array of letter counts. Now we can just call our backtracking function as we did all the time. So we can call backtrack. Now we don't need to, we no longer need to use words or letters. We just need the score, and we need the index in the words. So we can say I and score. Okay. And then we need to return result. And now basically the rest of it is just writing the backtrack function, very similar to what we did last time or last week. So this is going to be a void function. It will take an index I, and it will take an int array score. So our base case is when we're done with all the words. So we'll say if, oh, we need to give it a name. So we can say if I equals words length. We don't have access to words, but we have access to word counts, which is the same length as words. So if this is true, then we just maximize the result. So result equals max result and current and return. Now we have to check. So this is like our base case, right? When we're done, let's take whatever our total is that we got and let's try to maximize the result. So now the other thing is we basically are going to be on a word, and for a word, we're going to check. Oh, this shouldn't be I. This should be 0. Start at index 0. So for a word, we're going to check, like, do we have enough letters to make it? So let's do that. So what we can do is we can say for character C in words. We don't have access to, or sorry, we don't even need the characters anymore, right? We don't need the characters anymore. We have these word counts. And these word counts, we can just go through an array of word counts where we'll have letters 0 through 25, and then we just need to check, is that same value in our like letter counts that we have here? In fact, maybe we can call this letter counts to make it clear. So letter counts is like our total word bank that we have, or not a word bank that we have, our total like letters that we have. So letter counts. Okay. So we can say, yeah, so basically we just have to go through every letter in word counts for the word. So we can say int j equals 0, j is less than word counts I length. So our number of letters in our letter counts for, our number of letters in our letter counts for that particular letter has to be more than or equal to the number of letters in the word, right? So if like the word has 2 A's, we have to have more than 2 A's or 2 A's, and so on and so on. So every single non-zero value here, we have to have the same thing in our letter bank or more. So let's make a Boolean that we can make true. So we can say Boolean check equals true, similar to what I did yesterday. And now if we ever get a case where the word has more letters than we have, we can just make check false, and we can just get out of this. And then we're only going to use the word if we have enough letters to build it. So we can say if word counts I, j is greater than letter counts. And so j is the actual letter, so j. That means we don't have enough letters to build it, so we can just say check false and break. Now we basically copy this loop a few times. You can kind of argue what's better for performance, like, do I try to build the word, and if I can't, then I redo all my stuff, or do I check beforehand? I think beforehand's easier. So now basically if we can build the word, maybe we can call this like can build or something. So if we can build the word, then we're going to do that. So then we can copy this. Yeah, so essentially we loop through our letters. We don't need an if statement anymore because we know we have enough letters, but we need to actually update our character counts. So we'll say letter counts j, and we're going to subtract the number of characters for each character in the word. And so a lot of these are going to be 0, right? Because these are all linked 26 because I use an array, but it doesn't matter. I'll just be subtracting 0 and adding 0, which is still faster than using a hash map. Okay, so, and then we also need to add our score. So our score will be the number of the letter, which is right here, and the times the score of the letter, which is just letter at index j. So we're gonna, so essentially we're subtracting the letters, we're adding it to our total score. Now we have to backtrack to the next word, which is I+1 with the same score. Now after we backtrack, we basically have to undo all of the, actually this shouldn't be here. So this for loop builds the word. Then after we build the word, I might have too many here, I'll double check. After we build the word, we need to backtrack after the loop is over. And then we need to loop one more time and undo everything we did, right? Because that's the backtrack. So essentially it's just going to be opposite. So we will add the characters and we will subtract the score. Now, regardless of whether we could build this word or not, we're going to recurse and just try the next word. So here, this is our take, and this is our not take. If we don't take, we don't do anything, and we just go to the next index with the same letter count and same score. All right, so kind of lengthy. So let's see if we have any errors. Hopefully not. Nice. And you can see it's a lot more performant. You can try this with a hash map. I'm pretty confident it'll be a lot slower. So, but obviously if you struggle like figuring out like that, you know, like how does an A correspond to a 0 and so on, you can use hash maps. So basically you would change this letter counts to a hash map of letter counts. So your key would be the letter and the value would be a count. And then for this array, this nested array of word counts, instead of making a nested array, you would still have an array, but for each word, you would just make a hash map of letter counts. So for like word 0, you would have a dictionary, and then the key would be the letter, and then the value would be the count. So I can kind of show it quickly, kind of like this. So in Python, you can use a counter, which like does all the work for you. So it's decent much shorter. But yeah. So that's going to be all for this one. So let's talk about time and space and all that stuff. So essentially, what are we doing? So for every word, so let's go through the early part. Obviously for backtracking, like all this stuff is going to be, like, doesn't matter. Like if you go through all of your characters total, that's going to be basically nothing compared to the backtracking, because the backtracking is like 2 to the n times n or something. And this is just like you go through all the characters once, which costs you basically nothing. So you can say this is basically negligible in terms of time. This is the part that's going to be expensive. So for every word, we have the option to take it or not take it, which is 2 to the w already. Now also for every word, we have to figure out, do we have enough characters? And then we have to actually update our characters. So that's going to depend on the length of the word. So maybe we can call this like WL or something, or whatever, like length, I don't know, word length. So it's going to be something like this. Basically, for every word, we have the option to take or not take. In order to take and to even, in order to even check if we can, we have to go through the word and check all the, actually, this isn't going to be word length. This is going to be, so we may, actually, no, I think what this will be actually is of 26, the way we have it. Because we're not going through the word, we're going through the array of letter counts, and all of those are 26. So it's going to be like this. So you could say this is constant, and you can like plot that out if you want to. And then for the space, so let's see what we have here. So for this letter counts, this is only 26 letters, which is, you can say, constant. For the word counts, for every word, you have an array of 26 letters. So that's like of W because every word only has 26. So you could say like W or 26W if you want to or whatever. Then this is obviously these are just both integers, so that costs nothing. And yeah, so I think that's basically everything. So a lot of this is canceled out. That's why using letter counts is pretty efficient, even if you store every letter, even if you use 0 to 26, because there's only 26. So using dictionaries for letter counts for like obviously these constraints are really small, but if your word is like 1 million characters, using a dictionary for letter counts is way more efficient than using the actual word and going through it, because you're bringing down 1 million characters into 26 letters, which is a lot better. But yeah, so hopefully this is helpful. Hopefully these like performance tips were kind of good. Let me know what you think. That's going to be all for this one. So if you like this video, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.